All right, you're ready. We are C&E Engineering, and our project today is the bridge replacement in Blackburn, Missouri. Today we're going to go over an introduction. We're going to introduce our team and our company, our project description, our project scope, our design alternatives for the foundation, and our structural alternatives, our final design, and our cost estimate. So our organizational chart is our stakeholders in the project are Saline County, Missouri, and then CCP2 with Mr. Granville Quick and Michael Burns. Our faculty advisor is Dr. Samantha Islam. My name is Dylan Cass Stevens. I'm our team lead and structural engineer, and I'll let the rest of our team introduce themselves.
I'm Emma Sinclair, the civil site design engineer. I'm Anna Bro. I am the transportation engineer on the project.
I am Eddie Reyes. I'm the geotechnical engineer.
Yeah, I'm Kate Marty. I'm the water resources engineer.
So a little bit about our project description. Our bridge is located on County Road 432. It's also known as Adair Avenue. It is currently the fastest route to local greenhouses and farmland. However, it is experiencing some major cracking, erosion, and fluorescence, as well as flooding over top of the bridge when it rains. Due to these issues, soil is eroding around the foundation of the bridge, and also along the existing creek bed, causing it to not be accessible to large farming equipment. So part of this issue is because the large farm equipment is not able to cross the bridge, they're forced to use the 6.5-mile detour to get from the greenhouse to the city of Blackburn. If the bridge was accessible, they would be able to use the 2-mile route and get to the city a lot faster. For our scope, C&E Engineering proposes to provide these services, including flood analysis, the structural and bridge alternatives and designs, as well as foundation alternatives and designs, erosion control, stormwater management, and the roadway grade and tie-in plans.
So using software that extreme stats and information given to us from our client in Saline County, Missouri, we were able to determine that there's approximately 9,000 acres of drainage on our street. It's over Elm Branch Creek. Elm Branch Creek at our location is approximately 2 miles south of the Missouri River. And using a rain gauge that we were able to acquire the data from, we determined that there's approximately 42 inches of rainfall per year. And then for our design storms, we did the 10, 50, and 100-year return periods. And then we also determined that our hydraulic soil group of the area is groups B and D. Using the U.S. Army Corps of Engineers HECRAS software, we were able to determine the water depth for the trapezoidal channel under our bridge for the 10, 50, and 100-year return period storms. Using this, we were able to determine a bed scour depth of 2.1 feet directly under our bridge. Our creek flow rate for the 100-year storm was around 7,000 cubic feet per second. And then associated with that, we had a velocity of around 12 feet per second. So also for 100-year storm.
So our design alternatives for the superstructure and bridge are a Contact steadfast truss system. And Contact is a company that does accelerated bridge design and mainly steel bridges or box culverts. The estimated cost to use Contact services would be $600,000 with a month installation period and shipping time. These bridges are high maintenance, and due to the county that we are in, they have roughly less than 7 people that maintain every bridge and roadway in the county. So maintenance is an issue, and so is cost. So the next approach that we took was a steel plate girder bridge with a cast in place concrete top deck. The cost did go down significantly to $225,000 with a 3-week installation period, but also being high maintenance due to the steel and the high moisture contents up in that area. So the final design alternatives we looked at was a precast, pre-stressed concrete girder, FIB 36 or a Florida I-beam 36-inch with a cast in place concrete top deck. That cost came out to $218,000 with also a 3-week installation period, but it does have high shipping costs. So the choice we decided to go with was the FIB 36 or the Florida I-beam 36-inch. The span length is able to make the full bridge span of 80 feet with 4 girders being used at spaced on 6 foot on center. The girders will have a compressive strength before releasing tension of 6,800 PSI and a after release 28-day compressor strength of 8,500 PSI. The steel reinforcement used in this was determined to be 4 number 5 bars in the top with 35 number 5 bars in the bottom, with also number 3 and number 4 stirrups throughout the FOB 36.
And these are the different foundation alternatives that we consider. The first one consists of timber piles, costs about $75,000 to of the material and equipment, and it has a limited design life. The second alternative consists of other cast piles, costs about $180,000 and costs high soil disturbance. And the last alternative that we consider, it's driven H piles. Its foundation costs about $150,000 and will cost this soil disturbance. These are the characteristics of the foundation. It will consist of 4 piles with a pile length of 45 feet each. Well, an allowable axial compressive capacity of 28.1 kips per pile. Space 6 foot on center. And this is very easy to adapt and change on site. And it's composed with a high recycled steel content.
So considering the current bridge structure has scour problems at the foundations. Our solution to this was replacing riprap directly underneath the bridge. And then we determined our sizing of the riprap based on state regulations and state documents of 22 inches of a maximum diameter with a minimum thickness of 22 inches and a minimum diameter of 8 inches. The minimum weight of stone is 160 pounds per cubic foot. And then underneath our riprap layer, we'll have a bedding layer of durable limestone material. So approximately 10 to 15 feet on either side of our bridge, we'll be using geotextile materials in place of riprap. We'll be using permeable, non-woven geotextile materials to allow for the institution of vegetation. This is an economically, environmentally friendly, and will allow for the geotextile material will allow for the erosion control of the soil while the vegetation becomes established in the area. So our drainage ditches, when we have the new fill that will come with the elevation of the bridge, we have decided to run pipes, 36-inch concrete culvert. Pipes will be used to match an existing 2.3% slope. And with that, there's an associated flow of 90 cubic feet per second.
So for our site design, the current roadway is 17 feet wide, 1 lane gravel lane, and it has approximately a 0% grade on either side. So what we've decided was to widen that road to 26 feet wide, 2 lanes, and keeping it gravel. It'll have a 3% grade reaching to that 10 feet bridge deck with a 20-foot concrete approach. So in this picture, you see it's the new bridge and the old existing bridge. So what's hatched in the middle is the old existing bridge. We're going to have an 80-foot span length with 20-foot concrete approach tie-ins with 2 11-foot lanes with 2-foot shoulders on either side, which will result into 26-foot wide. For our elevation view, basically the same thing again, but the 20-foot concrete slab will have a 3% grade. The crack and riprap underneath our channel will be 2-to-1 slope, and underneath our concrete slab will be sandy clay fill, and then we'll have driven H piles. So the main 3 cost factors are superstructure design, our stormwater management, and our foundation design. Our superstructure design costs approximately $220,000. Our stormwater management is roughly $130,000. And then our foundation design is almost $115,000, resulting in $758,000 for a design like 50 years.
So we just want to say thank you for being here, and we'd love to have, if any questions come about.
Yes, I've got the traffic control. Probably between down.
So the main thing right now is almost all the traffic that goes over this bridge is high tractor traffic. Very few local traffic. The car does see an 88 DT of 35 cars a day, which is very low and most of it is tractors. So all of them now do use the alternative route that was shown at 6.5 miles. So it really doesn't see a lot of traffic right now. Being able to open it back up to those tractor trailers to get into the town would be a good factor for them. Well, it's about 3 weeks for the superstructure and about a week for the foundation, and then for all cutting and filling, roughly a month or so.
One we did that as well,
Mhm.
probably 2 months.
Mhm.
Did you check FEMA maps to see if there is any, if this area is any area of medium or high earthquake hazard areas? Because the driven pile solution works if you don't have that as an issue, but if it is, that's, it's a little problematic. So, there were obviously some soil conditions that caused the cracking of the current structure. So was that checked to see if that was an issue, that you had to think about?
Yeah, the all earthquake wind loads, live and dead were calculated in our superstructure and transferred to our pile caps to allow Edgar to determine pile sizes. But most of the cracking and erosion has occurred from void space being behind the foundation and unstable foundations and abutment walls. So that's the majority of the cracking has come from it.
So what's the current foundation?
Current foundation is unknown. We weren't able to tell the plans. The city had a building burned down that had all their plan sets in it. So they had nothing available pre-2018. So this bridge was built in 1966.
And how deep are your piles gonna go?
Taking account built, 50.
50 feet in the ground? Is that from existing ground surface or from the top of the bridge?
45 to land of the pile,
So,
and the tip elevation will be around 50.
okay. So what's your fill?
Sand clay.
It's gonna be sandy clay?
Mhm.
Okay, are probably outside your scope. I'm not gonna ask that question. Can you get back to your pile slide? Okay, yeah. So you say high soil disturbance for your auger cast piles. Well, in what manner are you just talking about this soil disturbance?
Due to the uncertainty of the state, so we assume the worst as possible.
Okay, so auger cast piles they're constructed by when you go out there and you're gonna have a big auger just auger into the ground. It's gonna be soil displacement. Or it's gonna be a non-displacement pile because you're taking soil out and you're just pumping concrete and throwing your rebar in. So that is gonna be actually a lot less soil disturbance of the surrounding soil stratum. So is that what you're kind of referencing here?
Yeah.
Okay, because driven piles are gonna be the vibrations from the hammer is going to disturb the surrounding soils. So that's something that I was kind of confused how you had that as low soil disturbance.
You're talking about like actually removing soil versus not.
Yeah,
Right,
yes.
or they're not moving soil, not actually like.
So you're talking about the actual, okay. So what about corrosion, since this is going to be next to water? Are y'all worried about that with your piles?
We consider a smaller pile size, and we took into account the sunlight on the account of the corrosion.
Okay,
The corrosion levels for Missouri were counted into the pile sizes. And also with this being mostly clay, the impermeable, but all of the piles will be behind impermeable clay, but also we'll have on the back sides of the bridge to protect our pile caps and our pile that's a part of that sandy clay fill will have sheet pile, small sheet pile walls protected from any water getting to it.
How did you determine the height and the length of the bridge?
So actually,
We determined the height based on the ECRAS modeling quality. So there's currently, the bridge deck is currently 15 feet above the creek bed. And it experiences flooding whenever there's 4 or more inches of rainfall. So basically we just modeled that in ECRAS and just raised it according to that, and according to the 100-year storm was the Was the highest thing possible.
Do you have any freeboard requirements above that?
So what we did was, the reason we chose 10 feet was 5 feet would get us out of that flood level, but it would still keep some of our exposed material in that flood level. So the 10 feet got us out of that where no exposed material would be in that flood zone.
Okay, and what kind of scour analysis did you do below the bridge for those velocities?
We just did that scour. Using the high grass software.
And can you build a Florida I-beam in Missouri?
So that's why we say it's on shipping costs. So they would have to be shipped from I think the most local place is North Alabama that they can be made at. So be shipped from there. But there's no local steel mills either near that area. So anything that would be used would still have to be shipped.
I don't think they haven't asked mine yet, so, so on your abutment, I hear you did, right, so. I know y'all had H piles as your, your actual, pile themselves, but your pile cap and they're gonna sit on, your garbage gonna sit on, you had that also as a H beam, or could you actually do like a abutment? Concrete abutment?
No, it'll be an H column. Welded at the bottom and anchored at the top. Welded studs to be able to run in with elastomeric bearings above the H column.
How are you going to retain the embankment materials behind the bridge approach? How will you retain the embankment materials at the abutment?
So behind the abutment, we'll have sheet pile walls, but all in front of the abutments, we'll have riprap to help protect any erosion. And the riprap in areas that are needed will be rock fill.
On your bridge loading design, I know you mentioned a large tractor several times, but was a particular like AASHTO weight class considered, or I mean, what was the actual
So
loading?
using used LRFD AASHTO design guide, but meeting with our clients, their loadings that they're taking over the bridges and the surrounding areas are higher than that. So I did account for that. They were stating that some of the local farmers do get their tractors up towards of 110 to 120,000 pounds loaded down, way over minimum or maximum requirements. So that was what I used for my design.
So I mean, if it's farmland, they never have heavy 18-wheelers per se that come and pick up product.
Not, they do, but mainly in the city area, not on the north side. Everything's shipped down to the city where they have some a small distribution center and everything brought down there. The city we're in has a population of less than 150 people. So everything they do is in the city. That's probably the main road that gets down to the city from the north side of town where all of our farmland is.
So your fill material, you said that was gonna be a sandy clay. Did y'all take into account any bedding material or some sort of filter fabric to make sure that doesn't? That
Yes,
fill
in
material
our, in our cost estimate, all fill material, the gravel for the road tie-in and the concrete tie-ins all have just that fabric material into the cost estimates. Any more questions?